I'm going to talk about the SSS Similarity Theorem. Okay? Let me type out what the theorem is, and then we'll continue. If two triangles have all equal corresponding side length ratios, then the triangles are similar. Remember that two polygons are similar if they have all equal corresponding side length ratios and they have all congruent corresponding angles. All right? So apparently the SSS theorem is telling us, at least for triangles, that we only have to establish part of the requirements, right? If we have all equal corresponding side length ratios, apparently we can assume that we also have all congruent corresponding angles. Okay? So let me show you an example. Give me a few seconds to draw a picture, and then I'll continue. All right, suppose you had these two triangles and you knew all the side lengths, but you didn't know anything about the angles. And you wanted to know if these two triangles were similar. All right, so you might think that you need to measure the angles in order to establish whether they're similar or not. But according to the SSS theorem, you just need to analyze the corresponding side length ratios. So what are the corresponding side length ratios? Well, can you see that one of them is 10 over 20? And can you see that that's equal to another one, which is 14 over 28? And that's equal to the last one, which is 12 over 24. So they're all equal to a half. Okay? So the SSS theorem says that's sufficient to establish that the triangles are similar. All right? Now, if you wanted to prove that the SSS theorem was true, let me show you how you would do that. So let me draw another picture, and then I'll show you what you would have to do. All right, so suppose we had a similar situation to the example I was just discussing. So suppose you have two triangles and you know that the corresponding side lengths are equal. So in other words, you know that b over y is equal, or let's start with side length A. And by the way, the side lengths are A, B, and C, lowercase a, B, and C. And for the other triangle, X, Y, and Z. And the capital letters A, B, C, X, Y, and Z denote the vertices of the triangle. So we can assume that A over X is equal to b over y is equal to c over z. Okay? Now, can we show that the triangles are similar? So I'll show you the steps you'd have to do, and I'll let you fill in the details. So on the big triangle, draw a line from one side of the triangle to the other, but not just between any 2 points. We're going to specifically choose the side length that let's call the points U and V. Okay, we're going to choose that so that x u is that length is equal to b. Okay, and also the line segment that we just created, uv, that's parallel to zy. Okay, so here's the plan of attack. You show that the small triangle inside triangle XYZ, you show that that's similar to triangle XYZ. Okay, you may recall that corresponding angles with respect to parallel lines cut by a transversal are congruent. So you can see that these angles are congruent. And then triangle XUV and XYZ, they both have angle X in common. Okay, so now you can use the AA similarity theorem to show that those two triangles are similar. Okay, now what you need to do to complete the proof is show that the new triangle I've created inside the big one, that little triangle inside the big one is congruent to triangle ABC. All right, once you do that, then you know that triangle ABC is congruent to triangle XYZ. Okay? So let me finish with you doing two exercises with regards to the SSS similarity theorem. So give me a minute to make a picture. All right, would you please pause the video and try to determine if these two triangles with the side lengths that I've listed on the board, if they're similar. Okay, so do that now, please. Okay, so I'll go ahead and work it out. So even without information about the angles, we can still determine if they're similar or not. So looking at the corresponding side length ratios, we have 4 over 8, which is equal to 5 over 10, but it's not equal to 6 over 11. So all the corresponding side length ratios are not equal. Therefore, we know beyond a shadow of a doubt that these two triangles are not similar. Okay? Let's do another example. Once again, let me draw a picture. Okay, so I've drawn two triangles with the side lengths listed. And again, without any information about the angle measures, can you determine whether or not these two triangles are similar? So pause the video if you have to, but work that out now, please. Okay, so as before, I'm going to start by analyzing the corresponding side length ratios, and I see that I have a 2 over 6, which is equal to 5 over 15, which is equal to 4 over 12. So all three corresponding side length ratios are equal, and that's sufficient by the SSS theorem to establish that the two triangles are similar. So we can state, without having to do any more work, that the triangles are similar. All right? And I hope that that is what you got.